So let's start talking about what's going on in containers. We're really excited to kick off Rackspace Solve San Francisco with a local company that has burst onto the tech scene by making it much easier to use containers. And of course, we're talking about Docker. So here's a quick video intro just to give you a little flavor of what's going on at Docker.
We feel that the time has come really to change the way that people think about how you create, develop, ship apps. I'm Ben GOLUB, I'm CEO of Docker. As a project, we have over 400 contributors, even though there are only 35 people in the office here. We've been downloaded close to 3 million times. We are deployed in lots of different use cases, from places like eBay and Gilt and Groupon, to lots of banks, lots of healthcare organizations. We've established great partnerships with folks like Rackspace. We think what needs to change is the notion that in order to make something portable, you need to take, the application, which may be measured in megabytes, combine it with an operating system that's probably measured in gigabytes, emulate a whole server and move that whole unit around. But in fact, there's a much simpler model, which is to simply containerize the application. We took a lot of the underlying technology around containers and said, if we made these really easy to use, portable between environments, accessible to the average developer or the average sysadmin, and built up a library for people to collaborate, the world could change. Basically, with the container model, you just take the application itself and its dependencies, and you run it in an isolated way on the host OS. We think it should be easier to ship applications from one data center to another than it is to ship car parts halfway around the world, but that isn't the case today. But with Docker and standardized containers and the kind of work we're doing with people like Rackspace, we're making that a reality. Collaborative approaches towards building, shipping, and running applications is really the way of the future.
Wow, that's a great video. Thank you. Look, this is Ben GOLUB from Docker. He's the CEO of Docker, and he's going to chat with you about what Docker are up to. Thank you, Ben. Welcome to Rackspace Solve.
Thanks a lot, John. So just to get things started, let me ask, if you are familiar with Docker containers, can you raise your right hand? And if you're not, raise your left hand. All right. If you sort of find yourself more on the ops side of the DevOps spectrum, can you raise your right hand really high and really keep it really still, sort of reflecting your interest in uptime and stability? And if you're more on the developer side, take your left hand and kind of move it around crazily and break something. And if you're a CIO, just pretend that the right hand knows what the left hand is doing. All right, so I'm Ben GOLUB. I'm from Docker, and I was given the topic of the future of applications. And it's interesting because I think if you really want to understand what the future of applications is, all you really need to remember is that developers, at the end of the day, are authors. They're content creators. And if you look at the entire history of publishing, forget about IT, but look at the entire history of publishing and what has happened. When we went from the only way to create a book was to be a monk sitting in a in a dark, dank cave, kind of like developers today, to having movable type and printing press. Suddenly, you started to liberate the act of creation from the act of replication and distribution. And then, of course, when you went from sort of movable type to the internet, and suddenly anybody could be an author, and you no longer had to worry about how what you created was going to be replicated and distributed and shared, the world changed in a really amazing way. I mean, I'm sure a lot of you have tweeted or published posts today, and you probably didn't spend a whole lot of time thinking about which routers your message was going to go through. And if we really believe that the internet is the computer or the network is the computer, then really the future of applications should be developers get to worry about creating amazing things and get to stop worrying about how they're going to be distributed, replicated, et cetera. Can't quite do that today, but we're going to get you there. So I'm going to talk a little bit about Docker, something we fondly call the matrix from hell, a little bit about containers, and then give you a sense of how the ecosystem is developing. But let's start with how apps have changed in the last 15 years or so. And 15 years ago, there were 3 things that were true that really are no longer true today. And yet most of the technologies that we have in data centers was based upon those 3 things being true. And those 3 things were that applications were long-lived. They'd live for 6 months, a year, or longer. They were monolithic and built on a single stack, and they were deployed to a single server. And all three of those things have changed. So development is iterative and constant. 40% of all organizations are releasing on a weekly or more frequent basis. They're built from lots of loosely coupled components that are themselves built on a multitude of different stacks. And of course, they're deployed to a multitude of servers. And so somehow, all of the change in applications and languages and frameworks and versions of applications and components that need to interact with each other, and all of the servers that they need to run on, from the development through tests, QA, staging, and production, once you're in production, scaling across clouds or between clouds or across clusters. The technology that we have in place that was based on the notion of one app equals one server needs to change. And so the problem in 2014 really looks very different. Again, what you have is you have lots of languages, applications, frameworks that are constantly changing that need to be deployed to thousands of different places. And the notion that you're going to be able to do that by having to worry about how all of these components are going to interact with each other and how they're going to be tightly coupled to the servers they're going to run on simply can't work. What we have right now is something that we like to fondly call the matrix from hell. But again, if every row is a language, framework, application, version of application that needs to run well with every other row and work well with every other column, where a column is where you're going to run it, it's simply impossible. There are lots of tools out there that have been built to automate away part of this matrix, to make it easier to take one row and make it work across multiple columns, or maybe make more columns look like each other. But those tend to be really brittle and break as soon as you add a new row or a new column, which of course is happening constantly. So how do we solve this? The inspiration for Docker's logo, and really for the company itself, is to look at the world of cargo. And back in the day, this was also a matrix from hell. And everything that got shipped was in its own specialized kind of packaging, and you'd have to worry about whether you're shipping your coffee beans next to somebody else's spices, and things had to be unloaded and reloaded every time you went from a ship to a train to a truck to a crane, and things were lost, and there was lots of theft. It took 10 days to unload a ship in port, and that all changed with a container. But it wasn't just a box. It was a container that was always the same size and shape, always had hooks and holes in all the same places. And suddenly we got to a place in world shipping where anything could be put inside one of these boxes. 95% of all world trade goes inside one of these standard shipping containers. You no longer care if you're shipping car parts, whether somebody else next to you is shipping bananas. And the same box goes from the ship to the train to the truck to the crane without being modified or changed or unloaded or reloaded. And that has spawned an entire ecosystem which has had dramatic impacts on the cost of shipping, the time it takes to ship, et cetera, et cetera. But I think more importantly, it's really changed the nature of manufacturing and the nature of world commerce. And at one level, we like to talk about this being a box. But again, it's not just a box. It's a box that's always the same size and shape with hooks and holes. And it's really not just about the shipping container either. It's about the ships and the trains and the ports and the entire ecosystem that is built up around it. And so if we want to make this future of applications work, we kind of need to do the equivalent. We kind of need to do the equivalent of creating a shipping container ecosystem for applications. And that's what we aim to do at Docker, and what we've largely been able to achieve with the help of a huge ecosystem, which is namely making it possible to take any application or its components, encapsulate it in a lightweight, self-sufficient container that can then always look the same on the outside, if you will, always start the same way, stop the same way, introspect the same way, log the same way, and so it can run on essentially any hardware platform. And today, if you come to Docker, you come to one of our conferences, or you see anybody who's using Docker, you'll see that they're able to Dockerize an application literally in seconds and deploy it in seconds without modification or delay, from the laptop to an on-premise server to Rackspace to some other lesser public cloud to OpenStack clusters, et cetera. And so what we've said is we've eliminated the matrix from hell, not by automating it away, but by essentially saying that every row looks the same to every other row, and every row looks the same to every column, and vice versa. So how do we do this, or how do we go about doing this? It's really a 6-step process to create this ecosystem. And we're going to start with the container itself. So container technology is not new. And I think the best way to understand containers is to compare them to what came before, which was the virtual machine. So again, virtual machines were created when applications were long-lived and monolithic and deployed to a single server. And the big problem we were trying to solve 15 years ago was we had a proliferation of single-purpose physical servers. We had one server for Microsoft Exchange and another server that was Mac Print. And how are you going to get all of those physical servers onto to be consolidated? And the answer was you took an application measured in megabytes, combined it with a guest operating system measured in gigabytes, emulated disk, et cetera, and basically turned that single-purpose physical server into a single-purpose virtual server. And it worked great. But if you're talking about the problem we have today, which is how do I take all of these applications and components that are more lightweight and microservices and I want to run them everywhere, there's a better answer, as long as you're willing to give up this notion of running completely different operating systems on other completely different operating systems. And actually, if you have an Android phone, you're already using containers today. If you downloaded Angry Birds, you did not download a VM. You downloaded something that was in a container. And in all likelihood, it hasn't screwed up your address book. What we've done is we've taken that same notion, that same sort of basic underlying technology that lets you run any application on sort of any Linux OS and brought it to the more complicated world of back-end server systems. And there are huge savings that come from getting rid of that guest OS. So just from a sort of operating efficiency standpoint, you can get significantly greater efficiency. And depending on what your workload is, that can be measured in sort of 20 to 50%, or it can be measured in density up to 80 times greater. These are not my slides. These are IBM slides. And not surprisingly, they put the good thing in blue, which is Docker, and the thing they were comparing it to in red, which was VM. No offense to companies that happen to have a red logo. That was completely unintentional. But of course, as I said earlier, shipping containers are not just steel boxes, and Docker is not just underlying low-level container technology. What you really need to do is you need to make these things easy to use, standardized, interoperable, automatable, and that's what we've aimed to do at Docker, not just with what we did at Docker itself, which is to make them easy to use, make the same container run on any server, whether it's physical or virtual or in the cloud or not. It's not only by building up a library, and it's not just by sort of helping you figure out how to tie different containers together, but it was really about creating a way for an entire ecosystem to work around it. So that was step 2, make them interoperable. Step 3, I'll go over really quickly, but we decided that even the base container technology was too heavyweight. We added this notion of copy on write, which essentially means if you have 100 different versions of an application that only differ by one library, you don't need to take up 100 times the space, or 100 times the networking, or 100 times the CPU. Containers leverage what's underneath them, or Docker leverages what's underneath it. And so if you want to update 1,000 running Dockerized containers with a security patch, you can simply do that by pushing out that patch rather than pushing out, or creating an entirely new VM, or restarting or starting an operating system. And later on today, when you hear Alex Polvey talk about some of the amazing things they're doing at CoreOS, you'll see that this concept really comes in spades. It wasn't me. So the final thing, of course, that we really want, or one of the next thing we wanted to do, step 4, is to turn this notion into an entire platform. And we talk about Docker as an open platform to build, ship, and run distributed applications. I'll start with this notion of the platform itself. Docker is an open source project. We'll talk about the momentum of that open source project, which is sort of anything you're going to see in the next several slides that's in green is open source Docker engine. We've also created an open hub, which is a set of platform-based services for distributed applications, again, for managing, monitoring, orchestrating, sharing content, creating work groups and collaboration around all of the underlying Docker containers. All of the APIs and the engine itself are all open, which has enabled us to, in a very quick order, and Docker itself is about 17 months old, enable anything that's created using this platform on any infrastructure, whether that's physical or virtual. Again, whether it's you want to run it on a full stack OS like Red Hat, a more minimal OS like CoreOS, you want to run it in the cloud on Rackspace, you want to run it in Amazon, you want to run it on an OpenStack cluster. The same Dockerized application, the same Dockerized container can run anywhere. And as far as managing it and manipulating it and tying it in to all the tools that you like, there's a huge ecosystem. There are now 10,000 projects on GitHub that have Docker somewhere in the title, and some 20,000 apps that have been published that are already Dockerized. So for all those base components that you want, or whether you want to use Docker with tools like Chef or Puppet or Salt or Ansible or Jenkins, they're there, and it's working. And what this lets you do is create an environment where you are building, shipping, and running applications in a truly revolutionary way. And if you go to a place like eBay or Guild or Groupon or any of the other folks that have started to adopt Docker, what you'll hear is that they have completely changed the way that they do the things on the left-hand side of the page here, which is the sort of dev, build, test motion, as well as on the right-hand side of the page, which is how they deploy things in infrastructure. And for those of you who've been around, for a long time, at least for 4 months ago or later, going from dev, build, test was something that often took weeks. And every time you went from dev to build to test, things that were working in one place would break, and you'd point fingers, and you'd move it again, and it would break, and you'd point fingers again. When we went from staging to production, it would break, and you'd point fingers again. Actually, at eBay, they said they wanted to implement a rule that if you pointed fingers, they would cut them off. But they said that only worked 10 times, and then they started to have a problem. With Docker now, with a Dockerized environment, the developer builds applications first by going to a centralized hub and pulling out standard libraries for things that have already been built. No need to reinvent the wheel here. For things that are unique to that developer, they actually go to source. They commit a change to source. And using something called the Docker file, we automate the creation of the build of a Dockerized container. That container gets picked up automatically by an automated testing system. And within minutes, 90% of the time, that Docker container passes all the tests and goes directly in production. And the 10% of the time when it doesn't work, it's really clear whether the problem was inside the container and the developer needs to change something, or it was outside the container and ops needs to change something. So no fighting, and what used to take weeks takes minutes. And that's a huge saving. What becomes even more exciting, though, or perhaps equally exciting, is that same Dockerized application or set of Dockerized components can then be run as a unit on any infrastructure. If your idea of the best infrastructure is a bunch of commodity boxes running Red Hat, it'll run there. If your idea of the best infrastructure is a bunch of commodity boxes running a minimal OS like CoreOS, it'll run there. If your idea of the best infrastructure is VMware-based, it'll run there. If your idea of the best infrastructure is to outsource all of it to somebody like Rackspace, it'll run there. And you don't even need to choose. You can move it back and forth between these environments and do so with 20 to 80x savings on density and things like that. So a pretty nice overall package. And what becomes really exciting as we look out a little bit into the future is that's not just a solution for more simple apps. It's a solution for very complicated applications where all of the components are themselves Dockerized, interact with each other in a consistent way, in a secure way, and then can run as a group or as individual components really across any server anywhere. And that's where we want to get to. And that enables us to move on to step 5, which is building an ecosystem. And perhaps for me, the most exciting part about Docker isn't even the technology, but it's this huge community that we built around us. So the Docker community now has actually now close to 550 contributors, of whom 25 work for Docker Inc. The rest are fantastic people who work elsewhere in the world. If you're interested in Docker, there are now 250 meetup groups all around the world. So if you happen to live in Jakarta or Paris or Hamburg this week, or you're going to be in some place really exotic like St. Louis, there will be a Docker meetup for you. There are hundreds of users who are actively talking about how they're using Docker. And in terms of content, we've got 20,000 and growing Dockerized applications. As a company, we offer support, both free and enterprise level support. And we've got a huge network of partners, including great people like Rackspace, but also IBM, Red Hat, Amazon, Microsoft, et cetera, who've all sort of jumped onto this bandwagon. And if I wanted to sort of talk about the full Docker ecosystem, it looks more like this. A huge set of fantastic companies, both large and small, both those who retrofitted to Docker as well as those who created de novo. And for me, it's an incredible testament to what you can get if you become truly open and embrace the community. And this, of course, is just a subset of all the tools and ecosystem that's out there. And if you want to talk about, want to find out how other people are using Docker, you don't need to take my word for it. You can talk to any of these companies or go to the website for DockerCon, which is our conference, which just happened about a month ago. And all of these people have presentations and talks that are talking about how they're using Docker, both the good and the bad, mainly good. And finally, step 6 is to build systems and infrastructure to take advantage of this new paradigm. And this is, again, where I think it's kind of useful to go back to the shipping container analogy, because as you may know, there were ports that won and ports that didn't win in terms of shipping containers, and shipping companies that won and shipping companies that didn't win. And the ones that won were the ones that really adopted it and took advantage, didn't just sort of do retrofits, but actually sort of embraced it whole hog. And Rackspace is clearly an example of a company that gets it, that understands Docker, that understands containerization, that understands that if you really embrace this, you can get massive savings in terms of efficiency and ease of use and time to deploy and time to update. And that really only is possible if you take this notion and you really embrace it. So we're really thrilled to be working with Rackspace, and hopefully you'll hear more about things like on metal in the coming talks. So conclusions, the world is changing. We think that the future of applications is going to change, changes in a way that really has never been seen before. And of course, part of it is the technology, and we think that, again, breaking the notion that an application has to equal an application server and creating things in a way that is standardized and interoperable is a huge part of it. But even more importantly is really the notion that you can take the internet and make the internet the computer. You know, I talked about publishing in my introductory remarks, and it's obviously very clear that the world changed when we enabled people to create fantastic content and stop worrying about the acts of distributing and the act of replicating. And you know, John mentioned something about data that was created, and you may know that back before the invention of movable type, you pretty much could have a single library that would contain all of the world's published information. And then, of course, there was an explosion of data, and if you got to where the world was, you know, before the creation of the internet, you obviously had a huge explosion of information, but you still could fit almost all of the world's published information, as long as it was in text form, on a couple of CD-ROMs. Now, if you took all the data that's been created in the world just in the past couple of years and tried to put it on CD-ROMs, it would stretch to the moon and back. And that's only growing. And that's, I think, a real testament to the power of liberating the act of creation from the act of distribution and the act of replication. And we're only starting to see that in the world of application creation and development. But I think if we really do this well, you will be able to take an application and run it anywhere in the same way that you can take a message today and send it anywhere without thinking about the routers that lie in between. We're really excited to be part of this revolution, and we think that Rackspace has certainly been a great partner in making this happen. So if you want more information, you can go to any of these sites. And now I think we have a couple of minutes for questions. So I'll turn it over to John.
Maybe just one question. I don't think we have much time, but
okay.
If anybody has a quick question for Ben? Anybody? We have a microphone. Slides be available. Can you share your slides?
Yes.
Okay, that was the question. The slides are going to be available. Ben is going to share them. We're going to figure out how to get you those, and look forward to a lot more with Docker. Thank you, Ben.
Okay, thank you, John.
All right. Thank you very much. All right.